This is a Sinclair ZX Spectrum. For so many, it wasn't just a computer, it was the start of a lifelong passion for coding, gaming and technology. I bought this Spectrum for parts not working, and it's clearly had a very hard life. But I'm sure it brought hours of fun to its previous owners, and I think it deserves another chance. So join me, turning this into this as I try to fix this Sinclair ZX Spectrum that I bought spares or repair on eBay. So here it is then, our Sinclair ZX Spectrum. This is an original rubber-keyed Spectrum. I say it's an original. I don't know what version of printed circuit board it has in here. I know there were several. I had one very similar to this, brand new in 1982. This particular example, I'm not quite sure when it dates back to. This isn't the one that I originally owned. I bought this spares or repair on eBay. Let's get this hooked up to a TV then and see what it's doing. Before we do that, we need to get it hooked up to some power. I think it's marked as 9 volts DC. I don't know whether that is center positive or center negative. When I got this machine, this is all I got. I didn't get any instructions, no manuals, no power supply. But it so happens that I have a ZX power supply here, which I got as part of a job lot. This is, I think, an original Spectrum power supply, I think. It doesn't have a plug on it at the moment, so we'll pop a plug on it, and then we'll take some measurements off this. So I have here a standard UK plug. I think this one has in it already a 3 amp fuse, which is what this probably would have had, or should have had originally. Probably didn't come with a plug. So we'll get the ends tidied up here. We'll get it wired into the plug. We'll power it up, and we'll see what happens. Okay, so with that done, not perfectly, but probably better than it would have been in 1982, or at least as good as that, we'll pop everything back together, we'll power this up, and we'll see what voltage our supply, if any, is giving out. Well, that is now plugged in. It's plugged in off camera, and nothing's exploded or caught fire. I don't hear it buzzing or anything, which is good, so let's put a multimeter on it. 13 volts. Wow, and it's supposed to be 9. Of course, it doesn't have any load on it. But we are relying a lot on the regulator there to 13.5 volts. What do you think? Should I chance it? Should I chance overvolting it? I don't know. I'm sure there's going to be a voltage regulator inside of here that's going to regulate that down. I do remember the one I had got super hot around there. So that was probably the heatsink dissipating some of that excess energy. But 13 volts is quite high. Of course, it is unloaded, so I don't know. Have a think about that. Quick browse online suggests that in fact most of the Sinclair power supplies gave around 12 volts, and that inside of here is a 7805 voltage regulator from which the other voltages are derived. And looking at the data sheet for that 7805, I think we're going to be okay to plug this in. So we'll go ahead and get this hooked up to a TV via this RF modulator. And we'll plug it into the power supply. And we'll see if we can tune it into a TV. Okay, so I think that's good news. What I see is copyright 1982 Sinclair Research Limited. How proud and excited I was to see that when I was 13 years old and I first got one of these machines. Now, there is a lot of noise on that display. I don't know whether that is normal, whether you would have seen that on a cathode ray tube or not, I'm not sure. And obviously, this yellowing that we see isn't normal at all. You'd expect that to be white. So it's quite a dirty video signal, which we'll have a go at cleaning up. Let's see if all the keys work, and we'll see if we can work out what size memory we have in this machine. So 1, 2, 3, 4, 5, 6. Well, there's certainly some keyboard input, which is great. Yeah, it's looking good. Brilliant. Okay, well, it actually looks like all of the keys work, which is fantastic as well. And I think there is a peak that we can do in order to work out whether this is a 16K or 48K machine. So let me go ahead and look that up. Cap shift and then symbol shift, and then the cursor changes to E, and then I can press peak, Fantastic. Okay, so the number is 23733. If we get 128, then we have a 16K machine. If it's 256, then it's a 48K machine. So let's take a look. Well, that's not everything I was hoping for. Yeah, I guess I have to print the value from peak. So let me try that again. 126. Oh my, this is a 16K ZX Spectrum. I don't think that's great news. Maybe a RAM upgrade will be in order, as well as the other upgrades that we're going to be doing to this machine. Let's just try the beep function. This machine has only a basic beeper. It's processor driven. There's no sound chip in this, which means that the sound on the game is pretty basic. Let's have a go though at that beep command. Okay, so the beeper seems to work too. So really, I think we're looking at fixing this display, maybe some memory upgrades. I'm going to do something with this power supply, or at least with the power regulation on this as well, and maybe some cosmetic improvements too. For now though, let's get this unhooked and have a look inside of it. On the back of the machine here, I see the feet have gone. Mine got so hot the kind of adhesive on the feet melted. I did notice the power supply has some little feet on that would fit, and my guess is they're more or less exactly the same. Let's get this opened up. Looks like there are 1, 2, 3 screws here. My guess is there are screws beneath here too, which are sort of hidden under some protection. I don't ever remember seeing that. It's just kind of filled with something here. Almost feels like blue tack or something like that. Okay, let's take a peek inside here and see what we got. Well, that is interesting. Let me just see if I can show you inside. It looks like we have all of the memory ICs populated. I'm going to need to do a little bit of research onto that. Keyboard connectors are intact. It's a membrane keyboard, so I'm going to very carefully kind of try and remove these, and yet still keep the camera rolling. These are extremely fragile. You know what? I'm afraid I'm going to have to sacrifice a little bit of footage in order to be very careful with the removal of this keyboard. Sorry about that, but I don't really want to have to... Oh dear, it snapped off. It's a shame you didn't get to see that, but it has just snapped off in the connector, as I feared it may. See if I can get this one off. The other one was very brittle. Oh, no, that also has torn off. Yeah, these membranes, which are connected onto the keyboard, have just torn straight off as I have tried to remove them from the connectors here. I just have kind of the remnants of the connector, or remnants of the cable in there, which I'll need to get out with some tweezers or something. Yes, so we got that one out. Yes, fantastic. Okay, so that's both of those clear. Unfortunately, as I say, the cable is just so brittle, and where it was folded over, it's just completely sheared. I'm just going to take a quick look inside, and I'm not going to dwell too much on this because most of my viewers probably know their way around a Spectrum already. Here we have the UHF modulator and the video encoder chip, the lower 16K of RAM, the upper 32K of RAM, the ROM, Z80 processor, or in this case a D780C-1 NEC equivalent, some glue logic, the Ferranti ULA, and of particular interest to us, the 5V voltage regulator, and the two potentiometers used to adjust the voltage offsets to the video encoder chip. These two pots here, I think, are the source of our problems with the video signal, from what I've read online, so we need to go and get those two adjusted and cleaned up. I'm also going to replace this with a more modern switching regulator, which hopefully will reduce the power consumption. We'll do something with this keyboard, we'll try and fix this RAM, and then we'll do some cosmetic changes too. So we better get started. Let's first of all get it away from the plastics. It looks to me like this screw has been used before. So I'm guessing I'm not the first person to have done this, but we'll see. Printed circuit board looks to be in reasonable condition, a little bit grubby. So a little something just kind of stuck in here. I don't know if you can see that. I doubt that is the cause of our problems, like a little piece of paper or something. I'm sure that's not a problem. Plastics seem okay, if a bit dirty. Maybe we'll start by replacing this voltage regulator with something more modern. Next, I'm going to use this barrel jack jumper lead to connect my bench power supply to the Spectrum. So I need to confirm how it's wired up and make sure the polarity of that supply is correct. So just looking how this is wired up, it looks like the outer, which I'm connected to here, is the black wire. And then the center, the center is the red. That's the opposite to how we actually want it for our Spectrum. So just need to remember that in fact it's this way around. I'm not going to set my bench power supply to the 13 volts that the factory supply was putting out because I suspect the voltage reduces significantly under load. Instead, I'm going to test what the loaded voltage of the factory supply is. We'll plug this in here. .43, so under load it's a more modest 10.43 volts. So we'll set our bench power supply to about 10 volts and that's what we'll use. And we can see when we plug that in that it's drawing about 0.6 of an amp. We're going to replace that with something which is hopefully more efficient. Removing the old voltage regulator is pretty straightforward. A single nut and bolt holds it and the heatsink to the printed circuit board, and it has just 3 pins that need to be desoldered from the PCB. The part that I'm going to be replacing it with is a Traco Power TSR 1-2450. This is a switching regulator and a drop-in replacement for our old inefficient linear regulator. Don't want it moving whilst I'm soldering it and just kind of being not flush to the board, so we'll hold it in place, hopefully nice and tight to the board. So with that in place, let's go ahead and give it a test. Well, nothing's caught fire, which is good news. Looking at our current drain now, we see we're at 0.39, so 0.39 of an amp, significant reduction in the amount of current that is being taken by the Spectrum. No heatsink anymore, no significant amount of heat, and hopefully no more melted feet. So I guess the next thing to do now is to make sure that it works. And well, it seems to work as well as it did before, albeit with our yellow kind of screen and all that noise. So maybe we turn our attention to this next. So I got some guidance from the excellent website spectrumforeveryone.com, but I didn't have the necessary manual dexterity to be able to probe the LM1889 video encoder while still adjusting the pots. So I soldered some wires to the pins of the video encoder instead. So let me explain what I have set up here. I have soldered wires onto pins 2, 3 and 4 of our LM1889, and I'm going to be measuring the voltage between pin 3 and 4 and adjusting VR1 in the hope of getting about 50 millivolts. So at the moment it's about 178. So I'm just going to try and tweak this around now. 49.9. We're going to leave it at that. But as we can see, the picture on the screen is still distorted. So having got the first voltage correct and leaving the ground probe where it is, the next step is to connect the positive probe to pin 2 of our LM1889. And now I'm going to adjust VR2, and I think I'm aiming for a negative voltage here. Yeah, minus 50 volts, so we're quite a way off on that one. It's going the wrong way, that's getting larger. So I'm in the negatives, and already we can see things are starting to improve over here. Minus 47. Okay, so I have a white screen. There is still some yellowing on there, and it's a little bit kind of patterned, which I really don't want. So I think I've got a bit more work to do on this yet. What I'm going to try and do is I'm going to try and hook it up to an oscilloscope and see if I can get any better than trying to adjust it with my multimeter here. So I've given up completely now on trying to measure those voltages with my meter, and what I've done is I've just connected my scope up here to ground and to the video composite into the modulator. So looking back as I'm editing this video, it looks like I didn't have the ground of the scope connected to the ground of the spectrum at all. And in fact, it looks like I've connected it to the 5-volt line. Whether this affected my adjustments or not, I don't know, and it didn't seem to do any harm to the scope or the spectrum. But it's another example of me doing something wrong, and another reason why you shouldn't copy what I do. We're going to power it up, and I'm going to adjust these so I get the cleanest possible signal on my scope. And what I'm aiming to do is get the flattest possible signal, so that way it's increasing. Here it's decreasing. Then it starts to increase again. So I think it's around there for this one. And then for this one I'm going to do the same. Increasing that way. Decreasing. Increasing. I think it's about there. It looks blue on the display. We'll go back and we'll tweak again. Yeah, I think that's about as good as we're going to get, unfortunately. Just out of interest, we'll go ahead and measure those voltages, see what they actually come out at. 36 millivolts on that one, and 26 millivolts on the other. But that seems to be the cleanest signal. I think that's probably as good as we're going to get. So the end result still isn't very good, but I feel I've done as much as I can. I've got it as clean as I possibly can on the scope, although it's still not terribly clean. And you can see there is a lot of noise on the display. So the only things that I can think of now are to either recap the board or replace this LM1889. So obviously, since there are a fairly small number of electrolytic capacitors on this board, the sensible thing to do would just be to recap the whole thing. But that might not be the case if you're repairing something other than a spectrum. And in this particular case, these caps are fairly easy to get to. So I thought it'd be interesting just to test them with the ESR meter, and then maybe we can find out exactly which one of these is causing our problem. So we have our ESR meter now, and the lower the better for these readings. So I'm just going to go through each of the caps in turn. I'm going to note off the camera here whether we've got a good or a bad or a marginal cap. So we'll start off with C28, and that has very, very low ESR, so that's good. And then we'll move on to C34. That also is a very good reading. And while we're here, we'll do C50. And that also is a good reading. Now, the value that you get, you kind of look up on this little reference table at the front, and there are reference tables available online as well, which go down to more detail than this one. That gives you an indication of, for the rated capacitance and associated rated voltage, what a good ESR would be. Anyway, so that's that one. I've got this kind of floaty one, looks like it was a patch at some later date. So we'll test that one too. This one isn't soldered to the printed circuit assembly, it's just kind of, well, it is soldered to the assembly, it's not soldered to the board. 1.49, 1.47, so that's perhaps a little bit more marginal than the other. Go on to C46. .86, and we'll do C27 as well while we're here. 3.17. So they also are perhaps marginal. So probably I will go ahead and replace those two anyway, because actually I have a couple of reasonable quality 105 degree C 1 microfarad caps. And that's some of the reason I'm not capping the whole board now as well, is because I don't have good quality caps to recap it with necessarily, not in all these values. So moving again on to C47. That seems to be pretty good as well. And then just move the board up here a little, and we'll do these two. Excuse the angle of the meter here. C44, 0.04, so that's good. And then C45, 10. So these two are identical, they're just in opposite polarities, at least mounted in opposite polarities. One of them 0.04 ESR, the other 10. So that's not marginal, that's just plain failed, I'm pretty sure. So that perhaps is the suspect cap at the moment. 0.34, that seems to be good in here. At this one, 0.4 again. At 22 microfarads, 10 volts, I think those readings are okay. Yeah, anything less than kind of 5-ish, something like that, and they are clearly less than that there, 1/10 of that. So I think these two are good. So really we just have these two that are maybe marginal, but this one which is clearly bad. So I'm going to go ahead and replace that one, see if it cleans up the video. Since I have good quality versions of these, I might replace these two as well. But the rest, I think I'm just going to leave in place for the time being. I will ultimately recap it. Please don't get too mad at me in the comments. But for the purposes of just getting this going and checking out the video, I think maybe obviously C45 needs to be done, maybe C46 and C27 as well. So unfortunately I don't have axial caps, so I'm just going to have to take some and bend the leads in a weird way in order to get them to fit. I'm not doing those two, I'm doing these ones. And I'm going to do one at a time because I noticed, and in fact read elsewhere, that the silk screen is wrong on this. So I'm going to do one at a time. I'm going to copy the orientation of the cap that I take out rather than follow the silk screen. And we're going to start off with C46 here. Okay, my camera stopped there for a minute, but I did try this, connect it up, and it made no difference. So this now is the part that I think is suspect. It's the part that I measured as suspect all along. It's the one that I think is going to make a difference. So we finally replace the cap that I'm pretty convinced has failed, and I replace it with a new one. So we have our replacement caps in place now. Let's plug this in and see how it looks. Not too bad at all. There's a little bit of patterning still on there. I don't know whether I'm going to get rid of that. This, of course, is via the RF modulator. So I think what I'm going to do next is we're going to hook it up via composite and see if it improves any still further. But actually, I'm quite happy with that. So just by way of a quick test of the composite signal output, I've got a clip lead here, which is connecting to the positive side of a 100 microfarad capacitor. That cap, then the negative side is going to this yellow lead, and then this yellow lead is going to the center pin on my video composite cable. The black lead here, I'll just clip to an earth somewhere, so we can probably just clip that onto the case or something. Let go. Yeah, fantastic. And then this is our video via our electrolytic capacitor. Does interfere with the image on the RF out a little bit, but of course we won't be using the RF out when that's running. So if we just take a look now at the composite signal, source, move across to composite, okay. And that's looking pretty clean now. There's a little bit of noise on there, and of course it could be a bit brighter, but I'm not going to go to the trouble of putting an amplifier in because I might just amplify up that noise. I'm quite happy with that as it looks. I can turn the brightness up on the TV if I wish. So I think what I'm going to do next then is make this a permanent mod and get rid of this kind of RF out altogether. Just use that as a composite out. So it's the following day now, and as you'll see, I've already replaced a couple of additional capacitors. I will likely replace the remaining 5 when they come in. In the meantime, I have decided I'm going to try and reseat this ULA. We'll go ahead and do that, and then we'll finish our composite mod over here. And we'll pop a little bit of contact cleaner on that socket and reinsert it. There are various ways of doing this composite mod I'm going to take, which is perhaps the simplest, and just put a capacitor in from the composite input to the modulator through to here, and then use the existing RCA jack as a composite output rather than a RF output, and disconnect power here. And now I'm going to desolder this composite in, which would ordinarily go kind of there in the modulator. And whilst I'm desoldering, I'm also going to desolder the existing connection to that center pin from within the modulator itself. That's the existing composite in wire removed, and we'll work out now a routing for our cap. And I think the pathway I'm going to try and take is I'm going to try and weave it through this and into the old hole. Well, it's not pretty, but I did get it in there and it's not protruding above the top, so I think that should be it. Let's get this plugged in now to the composite input on the TV, and we'll put the TV input to composite as well. Nothing. Oh, not plugged in. Ha. There we are. Well, that's not great, is it? I think it probably just needs a reset. Great. Not perfect. Still a little bit of a pattern on there. That might clean up if I improve these caps, but yeah, for now, really happy with that. Much, much clearer than on the RF, and certainly a lot better than it was when we started out. Next, I wanted to mention the polarity of the electrolytic capacitor that I put inside the modulator. Opinion in the retro community seems to differ on which orientation this should be in, and you may have noticed in my final implementation that I had the polarity of the capacitor the opposite to the way I had it when I was testing it with the clip leads. This wasn't intentional, but for what it's worth I tried it in both orientations and it didn't seem to make a difference for me. Mark Fixer Stuff suggests one way, Noel's Retro Lab another, and I don't know which is best, or if it matters at all. I also wanted to talk about some other video modifications that I'd made, but that I didn't include in the video because for me, at least, they didn't make any difference, and because I wanted to keep the length of the video reasonable. At the time this photo was taken, I'd already socketed the LM1889, but I stuck with the original chip because the replacements that I tried made no difference. You can also see that by this stage I'd replaced the electrolytic caps on the entire board. Not yet implemented on the photo here, but something which I also tried, was to replace capacitors C5 to C8 with 150 nanofarad ceramic caps. These are on the plus 12 volt line, and can help reduce what is called the jail bar issue, the vertical stripes which are barely visible on my machine, but are more visible on others. Neither of these cap changes made any difference to the video output on my Spectrum. I also considered using an amplified composite mod since I had a PCB available from a different project, but I instead decided to replace TR1 and TR2 with BC5479 transistors. These have a pinout which is different to the factory part, and so they should be inserted in an orientation which is the opposite of that shown on the silkscreen. This mod did result in a slightly boosted video signal. So I think next I'm going to do something with this keyboard. As you can probably see on the camera, it's in pretty poor condition. It's all bubbled up with rust. It's got some dents in it. There's no real way I can sensibly rescue that. The keyboard itself, the rubber keyboard, is actually in better condition than I remembered. I seem to remember this was quite badly worn, but actually I think maybe that's just a bit grubby. Never mind, we have plans for that. Anyway, keyboard membrane did function when we tried it, but unfortunately I lost some of the ribbon. It was very brittle when I disconnected it from the board in the first instance, so I might see if I can get away with shortening this. It probably would make sense to repair it, but I don't actually happen to have one. So we'll see if we can get away with it. Again, it's something that I could probably do in future if I decided I wanted to. So I think this just is stuck on. So I'm just going to get a spudger, see if we can get that removed. It was just stuck on. It isn't anymore, and as we can see, that keyboard is really absolutely disgusting. So we'll get that peeled away. I think this is deserving of a close-up shot. It is absolutely horrible. So replacement would be a case of just getting a new one of these, plonking it down there. As I say, this curve is nice and gentle, this one less so, but I'm going to just try trimming the ends at first, see if we can get away with this. I'm going to peel this back actually, I think, cut these two pieces separately. Trim the very end bits off. So it will sit neatly in the connector again, and then I'm going to trim this short. And pop a bit of capped on tape around that, I think. I don't think much is to be gained by trying to straighten that out. So a similar process at this side really. Well, hopefully this will work too. This one's a bit more raggedy at the end, so we'll try and get this again straight without losing any more than we have to. Probably chopped a little more off there than I needed, which is a little bit of a shame. Cut this one right back. I'll put some more capped on tape around that. Alright, I'm just going to check these tracks are conductive. I think they are, but just in case I need to kind of scrape anything else away, just check those are conductive. Yeah, great. Okay, so we'll pop this back through the keyboard temporarily, if I can remember where it went. We'll pop the electronics back temporarily in the bottom enclosure, and we'll see if the two will actually fit together, or whether I do need to replace this membrane. They might reach, but they could do with some stiffening behind them. By this stage you probably realise that I've messed up when I cut the back of the membrane a little bit shorter than the front. I feel like those would have been good to have there to kind of make that connection. I might see if I can find something that can stiffen that with. Just bear with me a moment. And the thing that I came up with was the plastic lid of a tub of cream cheese. With hindsight, I could probably have just stuck some paper tape or something onto the back of the ribbon cable. But cream cheese is the approach that I took, and after I'd cut a piece to the right size and attached it to the ribbon with capped on tape, it worked quite well. Well, they're sort of in. Before I put this back on though, I'm going to give it a quick rinse off. Okay, so do the keys work? I suppose that's the big question. Well, it's a good start. Fantastic, every key works. Well, I think I was lucky with that, really. Hopefully it'll stay that way for a while, but as I say, membranes aren't that expensive, so probably if I was going to keep this machine in the long term, I'd look to replace that. So with the electronics put aside for a minute, I think I'm going to turn my attention to some cosmetics. And I think what I'm going to do with this is I'm going to paint it. So I know that you can get coloured cases, replacement cases in black or a number of different colours, but actually, because I'm a bit tight, I'm going to have a go at painting it. I don't know how it's going to work out, but we'll see. If it turns out to be a disaster, I suppose I can always buy another enclosure. The tape that is on the edge that was holding the whole old kind of keyboard overlay in place seems to be similar to the stuff that was holding the ribbon cable together for the keyboard. That is, that you can kind of rub it away once you get it started. So go ahead and do that first. That's good. That's satisfying. I'm going to go ahead and just scrub this now with a toothbrush. Just get it really clean.
So as I finish cleaning off the keyboard, I have some bad news. I somehow managed to lose the footage of me spray painting the enclosure, so I'm going to have to talk you through the process. And of course, so that we don't get dust and dirt in the spray paint, it's important that we start with an impeccably clean location to do the painting in. So with an old cardboard box on top of my dusty Black & Decker workmate, and with the two parts of the spectrum balanced on some old paint cans, I set about spraying. As I say, I lost the bulk of the video footage, but by this stage I'd applied 2 or 3 light coats, leaving a few minutes between each for them to flash off. And here I am tripping over a miter saw as I go to fill in those bits that I'd missed from those previous coats. Now I do know that I should have the can in an upright position, but in order to hit those bits, I just had to angle the can as you see here. With hindsight, there should have been more distance between the bench and the item I was trying to spray.
So the parts are back now, having dried, and I must admit I'm quite happy with the way that they've turned out. I had to turn them over and just kind of spray a little bit around the edges to catch some of the bits that I'd missed. Some of those from certain angles might just still be visible, like this black rim around the edge here. I'm not too sure. I did, I think, get them on the bottom. Yeah, so the bottom piece, I did remember to spray those parts. But on the top piece, I didn't turn it over and kind of spray those inner edges. I don't think it's going to be too much of an issue when everything's put back together. I don't think it's going to detract too much from the overall appearance, but just something to be aware of. I think if I were to do it again, I'd take a little bit of time just to spray those interior pieces there. Unfortunately now I use the whole can of paint. I've run out of paint, so I can't go back and touch those up. But overall, I'm really happy with that. So I'm going to go ahead and get it assembled temporarily. We'll give it a quick try, and if everything works, we'll get the kind of final installation put back together. One thing I want to go ahead and do now is make up a cable. Now, we could just use a video cable and then the beeper from the Spectrum as nature intended, but it is a feature, if you like, that the sound does come out of the earphone jack. So I'm going to use that now as a sound source for the sound into the TV via this composite cable.
So I have to ask myself as I wait for this 48K game to load, what happened to us thinking that this machine was only 16K? We know that it had the full complement of RAM chips and they were soldered into the board, so that likely it was 48K from new. One possibility is I used an incorrect peak to ascertain memory size, and although the peak that I used wasn't conventional, I think it was still good. So my theory then is on the only chip that was socketed on the board, the ULA, and that perhaps when we removed the ULA, cleaned up the socket and reinserted it, we made a fresh connection on one which was previously troublesome, and as such restored the 48K functionality. It's been quite the journey for our rubber-keyed Spectrum. From a dirty machine with a distorted and yellowed video output, a 16K inferiority complex, inefficient voltage regulation, and an RF out, to what I think is a quite attractive, clean, upgraded, and 48K machine. But that does just about wrap it up for our Spectrum for today. I hope you've enjoyed the video, and that if you have, you'll hit like, because people tell me that hitting like means a lot to the algorithm. And maybe, if you really enjoyed the video, you could subscribe too. But until next time, I'd just like to thank you so much for watching Retro Tech Repair.
Now the plate, oops. And back. And off we come with the lid.